I had done a fair amount of research before I moved to the Dauphin Island Sea Lab. We had found that oysters will grow a heavier, stronger shell when predators are present. We figured out using funding from Mississippi Alabama Sea Grant that it's something in the urine of the predators. In a sense, oysters smell a scent or a chemical signal from a predator, usually a blue crab, and then they develop a harder, stronger shell.
We used the Predator Q research with Mississippi Alabama Sea Grant because we were hoping to see harder shells on the oysters. What that means is when we deploy the oysters onto the natural reefs, they have a better chance of succeeding in their growth and their life cycle to help repopulate the natural oyster reefs.
So the reason why predators don't want to eat oysters with a harder shell is because many of the predators that eat baby oysters are themselves really small and tiny. It's a lot harder for them to break into the shell. It takes more energy, it takes more time, so they will switch to another food source entirely.
We thought if we could toughen them up using predator cues, we could increase survival and make oyster restoration more effective. You obviously want your restoration dollars to go as far as you can because those funds are limited. So Mississippi Alabama Sea Grant provided us the initial funding to show that we could do that on a really large scale, to simultaneously expose millions of oysters to a predator scent and then cause them to toughen up their shells, and then we put them out in nature and showed that this does increase their survival.
We've partnered with the Oyster Gardening program, which is a network of citizen scientists where they've provided access to their private docks for us to grow oyster shells. And some of these citizen scientists are able to grow the oysters for us and maintain them, and sometimes we have to maintain them. So we, once a week, have to go out to these cages of oysters that we have and make sure that they aren't becoming too biofouled. It also entails locking the cages down in case a big storm or hurricane is coming through. We don't want our oysters to just blow away or get tossed out into the storm when that happens.
We had partners that were at the Alabama-Florida border all the way to the Mississippi-Louisiana border. So we were able to span over 100 miles of the Northern Gulf and capture how natural variability in the ocean, salinity, temperature, and so forth affects oyster growth, but also if they're exposed to predators, how do they perform under these different conditions?
We've been partners with the state of Mississippi since 2017, specifically as oyster gardeners for restoration purposes for our state, to help bring back our oyster populations. And from the students' perspective, it's cool because they're citizen scientists, they're helping with Mississippi's oyster population, but they're also looking at it through a different lens. When you start having scientists with real-world projects come to us, asking for our help and wanting high school students to help them collect that data. And it gives them another tangible aspect of stewardship and restoration. And it gives them another opportunity to experience something that most high school students don't get to experience.
This oyster reef is a really good example of multiple end users working together. So the Nature Conservancy built this marsh. We added an oyster reef to it. It helps protect the marsh and protect their investment. It causes the marsh to expand. And it's a really good example of end users and collaborators working together to achieve, a greater thing than either one of us could do on our own.